Now let's stick with our 6210 example. And here's the transition matrix again for that 6210 example. And now I want to look at powers of P. So I want to look at P to the K for big K. And then we're going to see some interesting properties about this matrix. Now once again, what we saw before, the square of this matrix. So P squared is this matrix. Now let's look at it for big K. So let's look at it for P to the 10 and P to the 20. Now actually, if you like to code, I would just code it up yourself. Take this matrix and look at powers of it for big K. Or take a different matrix. Make up a matrix and look at powers of it for big K. Just make sure that it's a stochastic matrix, so each row sums to 1. Then it corresponds to a Markov chain. So this is the first row for P to the 10th. And here's the second row. Notice that it's quite similar to the first row. Is that just a fluke? Let's look at more rows to see whether that was just a fluke or it has some important properties. Now the exact numbers in this matrix aren't important, but what's important is this interesting property that seems to be coming up. All the rows seem to be converging to the same value. Now there's still a little bit of variation, look, in this third column. Let's see what happens for P to the 20th. While looking at the first column of P to the 20, we notice that it seems to be converging quite nicely. They all agree on the first 4 significant digits. If we look at the other columns, we see that those are converging quite nicely as well. So what's our conclusion? Our conclusion is that there seems to be a row vector, and all of the rows are converging to this row vector. Now let's look at this matrix, see what it means. Take any particular column. Let's take column 2. Now let's look at this entry 1, 2 in this matrix P to the 20. What does it mean? Well, it means if I start in state 1 at time 0, what's the probability that I'm in state 2 at time 20? Well, that's exactly this entry. Similarly, if I start in state 2 or 3 or 4, what's the probability that I'm in state 2 at time 20? Well, regardless of where I start in, it seems like it's independent of where I start in. At time 20, it's going to be exactly this. And if I look at a larger time, then this is going to converge even more. So there's going to be a specific probability that I'm in state 2 for big time, regardless of where I start at time 0. So that's the key property of these Markov chains. Regardless of where you start, it doesn't matter. If you look for big time, I'm going to converge to some value. So where I am at some big, large time is independent of where I start. Let's say that again a little bit more precisely.